Hello, and welcome to this Cossan tutorial, which is part of the Cossan Training course on uncertainty quantification. This tutorial is about building and using a simple Credal network model with the Bayesian network toolbox in OpenCossan. I'm Diego Estrada Lugo, and I'm a PhD student at the Institute for Risk and Uncertainty, and also part of the Cossan working group. During this video, we're going to explain how to import all the necessary packages before building our model. Then we are going to define the nodes, build the network, visualize it, and finally we are going to do predictions as well as diagnosis using the compute inference method. From our past tutorials, we know how to download and install the Bayesian network toolbox of OpenCossan. In those videos, we showed how to install the developed version of OpenCossan and all the submodules needed to build our Bayesian networks. We are going to show how to use that toolbox for Credal nets. So if we go to an empty script in MATLAB, we first have to start importing our packages needed. So we just name this example. Okay. Okay, and then we import the Credal network package. That's where we're using Credal networks. Credal node. If you remember from our past tutorial, we imported the Bayesian network and the discrete nodes. In this case, since we are using Credal networks, we have to import the Credal network package and also the Credal nodes. In case we are using a mix between discrete nodes and also Credal nodes, we have to import those nodes as well. So we have to import those packages as it's just here, as a discrete node. Okay, this is only if we are using also discrete nodes as in Bayesian networks. Okay, and then we have to initialize OpenCossan. So for that we access the function okay, then we initialize our network. So we put the counters that we need to define our nodes. So as I told you in the previous tutorial, we are going to use the example of the smoker and to diagnose the probability of getting him cancer or bronchitis. So first we're going to define our node smoker with states true and false. True, and state 1 is going to be false. Okay, and then we add 1 unit to our counter. Okay, and then in Credal networks we have to first define the lower bounds and then the upper bounds in different cells. So we're going to start from the, let's call it smoker, and let's call it lower. Okay, so first we have to define our lower bound cell as we saw in the previous tutorial. Since this is a root node, we only have to specify the number of states that this node will have. Okay, and then we access our entries for this node. So in this case we can see that the lower bounds are 0.25 and 0.5. So 0.25 and 0.5. Okay, and then we define this cell containing the upper bound. Okay, so we define the same way a cell containing the upper bound, and we do the same. Okay, we just do exactly the same as we did with the lower bound. Here we can see that the upper bounds for the state true is 0.5 and for the state false 0.25. Okay, and then as always we define the properties of our node. In this case we're using a Credal node. Okay, so remember that in the previous tutorial we saw that we were using a discrete node. In this time we are using Credal nodes. Okay, so we define the name, in this case going to be smoker, and then since this is a Credal node, we have to specify the lower bound, which is going to be this one here, and then the upper bound through passing this cell as the upper bound. Okay, and this is a root node, so we don't need to specify the parents. Okay, our next node is going to be cancer, probability of the patient having lung cancer. In fact, this lung cancer. Given that we know that given if the patient is a smoker or not, so true or false are the states of this node. So again, we add 1 unit to our counter, and then we do exactly the same as before. So I'm just going to copy this CPT here. In this case we're going to call it C for C cancer. Okay, and then since the parent has 2 states, we need to create a cell of 2 by 2. Okay, so the lower bounds, when cancer is true, sorry, when smoker is true and cancer is true and false, is going to be 0.15 and 0.6. And when cancer is false, sorry, when smoker is false, it's going to be 0.5, 0.05, and 0.1. Okay, now we define our upper. No, we don't want to convert all of them, just this. Okay, so the probability, the upper bound when smoker is true is going to be 0.4 and 0.85. Okay, and then when smoker is false, it's going to be 0.1 and 0.95. Okay, as we can see, the lower bound of one state and the upper bound of the complementary state is sum up to 1, so we are using extreme points as we're using the strong extension of the Credal networks. Okay, so we define the properties of this node, which in this case is cancer, and then we just pass the CPTs, and then since this is a child node, we need to specify which are the parents as strings. Okay, so in this case is smoker over here. Okay. Okay, and then we do the same with our next node. Okay, so let's just create the title for this node. So this is bronchitis. State 1 to be true, state 2 is false, and also it's depending on smoker. Okay, so I'm just going to copy the same structure as before, as our cancer node. So in this case, I'm just going to call it CPD lower. Okay, we also need it here, and then we do the same for the upper bound. Basically, since the structure is the same, we're just going to repeat the same procedure. So the probability of cancer, of bronchitis, the lower bound when smoker is true, is 0.3 and 0.55, and then when smoker is false is 0.2 and 0.7. Yep. And then the upper bounds when smoker is true, 0.55 and 0.7. Those are the upper bounds and then for bronchitis, and then when smoker is false, the upper bounds are 0.3 and 0.8. Okay, so everything seems to be correct up to here. So here we just call it with the name, and then the parent is going to be again smoker. Okay, so what's next? We need to build our network. So how do we do that? We just need to create a variable. In this case, let's say we call it cancer net. Yeah, and then we're going to use a library that we imported, which is going to be Credal network. Okay, so we use the Credal network, and then we just need to pass the nodes that we just defined. Okay. Note that if any of these nodes are just discrete variables, discrete nodes, we still need to use the Credal network, because there will be some other nodes that will be using the Credal node properties, and in that case we will need the Credal network packages. Okay, so just if one of your Credal nodes are, so one of your nodes are Credal, is a Credal node, that's only enough for you to use the Credal network. Okay. Okay. So now we are going to visualize our network. So just going to visualize. Okay. So as before, we just call the makeGraph function. Okay. Before running this model, what we are going to do is first check that the paths that we are using are all, they are not paths of other versions of OpenCossan. Okay, so as you can see, I'm only having the added paths to MATLAB, only the ones related to MATLAB libraries. Okay, and then we need to check that we have installed our computational biology toolbox, as well as the machine learning and optimization toolbox. Okay, the optimization is in general for OpenCossan, but for Bayesian networks we will need this computational biology toolbox. Okay, so our workspace is empty, so we just need to save this as smoker tutorial. Okay, we just save it, and probably I'm going to have some spelling issues or some problems, but MATLAB is going to tell me what's wrong here. So let's see, let's run it. Okay, it's initializing OpenCossan. Okay, and we can see here the structure of our network. Okay, so now what we have to do for inference, so let's say that we want to know what is the probability of the patient having cancer, given that we observed that the patient has already bronchitis. Okay, so let's say that we want to see if the patient has cancer, given that we already know that it has bronchitis. Okay, so let's just name it cancer given bronchitis. Okay, so we just need to use the compute inference method. Okay, and then we want to compute the marginal probability Okay, of which node? So we want to know the probability of the patient having lung cancer. Okay, remember that we have to call it, pass it as a string, pass the name of this node as a string. And in the previous tutorial, remember that we needed to say if we want to use the Bayesian network toolbox. Okay. Okay, so we have to say if we want to use this toolbox, so we just need to say that yes, we want to use this toolbox. Then we insert our evidence. So we pass we pass bronchitis node as our observed node. This is our evidence. Yeah. So it's going to be that it's going to be on the state 1, and then which algorithm we are going to use. This time we're going to use the junction tree algorithm. Okay. So let's see. Just check that everything is fine. Probably I'm going to have some errors. I'm just going to run it and see what happens. So I'm just going to select this part, this section, and evaluate it. Okay. Oh, so everything run fine. So if we want to see the posterior, we just need to access the variable containing our query, and then access the properties. In this case, it's going to be cancer. And here it is. This is the join. This is the posterior probability of a patient having cancer. Given that we know that he has or she has bronchitis. Yeah, this is the lower and upper bounds of the first state, which is being true. This is the lower and upper bounds of the false state. Okay, so let's just try with the other algorithm. So the same, we are just going to use variable elimination this time. Okay, so we need to write here elimination, the algorithm that we want to use. Okay, and we should get the same number here. As you can see, variable elimination is computing a bit faster the posteriors. So as you can see here, the values obtained are the same, but with the algorithm of variable elimination is much faster. Okay, so now let's try with let's do something. Let's try. We want to know now the probability of the patient being a smoker, given that we know that the patient has bronchitis. Okay, so we we just want to know that either what's the probability of getting the diagnosis of bronchitis being as the patient being a smoker. So we use the same variable elimination algorithm with the BNT toolbox. Okay, and in this case we want to know smoker. Okay, so we just select this part, evaluate this section. Okay, and then just need to see. Okay, so this is the probability. This is the lower and upper bound of state 1, which is true, and state 2, which is false. Okay. And just as a last example, we are just going to perform a simple marginalization. So we want to compute the marginal probability of having the patient having cancer. Okay, so in this case we don't want to use the evidence. Okay, so we just want to see if this patient has cancer. Yeah. Okay. So we evaluate this section. Okay. This is our results. As you can see, also it's given as an interval probability, the posterior, and we're just going to try with the built-in toolbox. Okay, so false without the BNT toolbox here. So no BNT. Okay, and we should get the same. Oh, did I? Okay, as you can see, the values obtained are the same, but it takes a little bit more time when we use the built-in toolbox. Okay, so for you to consider this in your models. Okay, so in this video we have covered how to initialize our Bayesian network toolbox for OpenCossan, how to build a simple model, and how to make predictions and diagnosis using the Credal networks. So in our next videos we're going to see more functions of the Bayesian network toolbox in OpenCossan. As always, for problems launching the Bayesian networks toolbox, you can contact us to these email addresses. Thank you and happy Cossaning!